We're acting normal, right? Section 4.3. Now, you've been dealing with your exponential functions, and that was your quiz that you just took. Okay, your quiz you took with it there, but we're very limited on what we can solve for with the skills that you currently have. If you think about what we solved for with our compound interest problems that we had, we could find our principal and we could find our amount, but you were always given the rate and you're always given the time because those are in our exponents. Well, what happens if we want to find the rate? What happens if we want to find the amount of time that it was put in for? We have to have a new set of skills. So that's the start of where today's lesson is coming into play. Okay. Now, on your first slide that you have, your exponential function, I put the graph here so that you could, I'm going to show you what it looks like today. We're not going to do any graphing today other than this first slide. There's no graphing on your homework, but we will have graphing tomorrow. That's the focus of tomorrow, is to bring the visual with the definition that we're going to do today. Okay. Now, anytime that you have inverse functions. Now I think about the word inverse and I think of what you already know about inverse. If I say, what's the inverse of addition? You would say subtraction. What's the inverse of multiplication? You would say division. What's the inverse of the square root? You square it. What's the inverse of an exponent? Is a log. So that's what we're talking about today, is the inverse of the log. Now, if we graph inverse functions reflect across the line y equals x. So if you look at this diagonal blue line that is on your slide, that diagonal blue line is the line y equals x, and I marked it that way up in the corner. I don't think that it was marked on yours, so maybe write that so you know that it's there. Okay. But what happens is we're going to take that exponential function that we have and we're going to fold that piece of paper on that diagonal line and it's going to lay on the other side. And that's what the graph of our log is going to look like. So if you think about up here, we have ordered pairs that are x, y. We have an ordered pair that's 0, 1. We have an ordered pair that's 1, 2. We have an ordered pair that's 2, 4, and so on. To graph our inverse, we just graph the other order. We graph yx. So on this side of our graph, we're going to graph yx instead. So instead of graphing 0, 1, we're going to graph 1, 0. Over 1, up 0. That's reflected across that line y equals x. And instead of graphing 1, 2, we're going to graph the point 2, 1. I'm going to go over 2, up 1, and I'm going to hit my graph. Instead of graphing 2, 4, we're going to graph 4, 2. Over 4, up 2. One more point that we had, this was negative 1, 1/2. So instead of negative 1, 1/2, we're going to graph 1/2, negative 1, over 1/2, down 1. Now in our exponential function, all of these dots along the side keep getting closer and closer to 0. So all of these dots along the side are going to keep getting closer and closer to x equals 0. So your graph comes up through here and goes like this. Our exponential function has the y equals 0 asymptote. For your log functions, Brady, we're going to have our asymptote is going to be at x equals 0. We're going to get really close to that line 0, but we're never going to touch it. Okay, that's the electric fence here. That's one of the points that we're going to talk about moving. The equation for this pink dotted line is x equals 0. That's a known asymptote. That's what we're going to be shifting left and right. Okay, the other key point, once again, when we talk graphing tomorrow, the other key point we've got is that 1, 0. Those are the two key parts to your log graph. Okay. Places in real life where you see logarithms and you use logarithms, when California has an earthquake, it's on a Richter scale. That Richter scale is a logarithmic scale. So we can utilize that log scale, talks about how far out was the earthquake felt. We can figure that out as we go through. Okay. Other places where you use logarithmic functions are going to be sound intensities. Think of the quietest whisper, a pin hitting the ground. Think about the loudest cymbal bang as you're standing right next to it. in band and how loud that is. Those sound vibrations are logarithmic scales. So we'll be talking about that use as well. Okay. Equation for the blue line that we just wrote is y equals log to the base 2. It's a subscript of x. That's our start. That's where we're at. Okay. And you can't put into your calculator anything that doesn't have a base of 10 or a base of e. And we're going to talk about that coming up. So there's limitations of your calculator. And then we'll learn some cool features that will help you do better with things. Okay, we can't just put log to the base 2 of x into our calculator and graph it. Okay. Next slide. Now this is where you need your note cards out. Make sure that you're putting your definition on your note card. Your definition, of course, is in one of the ivory boxes in your book. Are they ivory or are they blue? I guess I don't know for sure. The ivory boxes, I think. Okay. So on page 248, the definition, or 249, the definition of your log is on page 249. Definitely something for you to look at. This stuff it kind of hurts your brain because you've never seen it before. And so we don't really have an understanding of what it is. So I want you to get what's in the box on your note card right now. And I'll just pause and I'll wait for you to write that onto your note card so you have it. Placement of those variables is important. The x on each side is the same number. The y on each side is the same number. The a on each side is the same number. When we started the school year, we talked about radical rules and exponent rules. Maybe we said, here's the square root of x, and we said we could write that also as x to the 1/2 power. Those two things are the same, and it took training your eyes to see that every rational exponent we can write as a radical function. Okay? Every exponential function can be written as a log, and every logarithmic function can be written as an exponent. So how we kind of teach you to deal with logs is we teach you, if you see it like this, rewrite it like that and use your exponent rules because you're better at those. So what we're talking about here is when this is red, y equals log to the base a of x. And it says if and only if x equals a to the y. Couple things about this that I want you to take note of. We said the word base here with our a, and the base of our exponent on the other side, the bases are the same. So you're going to keep those bases in the same spot. Okay. What we take the log of, that x goes on the other side of our equation. Our y value, this part when we rewrite, becomes our exponent. The y value that's right there becomes our exponent that's up there as we're rewriting things. Couple of limitations here, couple of rules. It only exists in certain spots. Our x values, what we're taking the log of, has to be greater than 0. We cannot take the log of a negative number. We can't take the log of a negative number. It's kind of like the first time you learned about taking the square root of a negative number. You said you can't do it, it's undefined. And then we talked about imaginary numbers. Okay, so if you have a log of negative 10, if you have log to the base 2 of negative 10, that doesn't exist. Your answer is undefined. It's an undefined value when we're taking the log of a negative value. In a similar manner, our a greater than 0, our base, the base for our log and the base for our exponent, that also has to be positive. Our base has to be positive. Okay, and it's limited. Our base cannot equal 1. And if you think about it, if we had a base of 1 in our log and we rewrote it as an exponent, 1 to any power is always going to be 1. So it's a special case. That's why our base can't be 1. Okay. Any questions so far with the look of this? Yeah. And you can't put the base into your calculator. Okay. So we'll talk about evaluating without your calculator, and we'll talk about using your calculator coming up. Okay. In certain instances you can, and in certain instances you can't. Okay. Yep. So like this one I couldn't put into my calculator. That would just, yep. Okay. Now, as you look at things here, if I'm transitioning from log, this is my log form right here. Okay. My base is 10. And I'm taking the log of 100, log to the base 10 of 100 equals 2. As you're numbering a test, instead of writing the number 2, I could go log to the base 10 of 100 in that spot instead of calling it number 2. They mean the same thing. Would you rather see the number 2 on your piece of paper, or would you rather see log to the base 10 of 100 on your piece of paper? Probably the number 2. That's my guess. Okay. If we use our definition, we take our base, we raise it to this power, so 10 squared equals 100. Is that a true statement? Does 10 squared equal 100? Yeah. Okay. They're equivalent statements. So every time you see a log, you're able to rewrite it in terms that maybe look nicer to your eyes. Okay. So as we scroll on down, keep your note card handy so you have the rule, because I don't have the rule written on this particular part now. Okay. The first part of your assignment is going to have you rewrite each log. You're going to look at the log and you're going to rewrite it as an exponent. So you want to keep your base the same. My base right here is a 2. So I'm going to go off to the side and write 2. The base of my exponential function is a 2. The exponent is what's on the other side. The 5 is my exponent. Equals the number that you haven't used, whatever you took the log of 32. Is 2 to the 5th power equal to 32? Yeah, it is. Okay. Keep your base the same. The answer to the problem is your exponent. What you took the log of is on the other side of your exponential function. Number 2, our base is 3. Start with your base. My base is 3. The other side is our exponent. 3 to the 0, what number is left? Goes on the other side. Is it a true statement? 3 to the 0 power, does that equal 1? So anything to the 0 power is 1. That's my favorite rule, Cody. Freshman year. 3 to the 0 power is 1, man. Okay. Number 3, your base is 10. So I start with my base. The other side becomes my exponent. To the negative 2 equals what's left? 1 over 100. Are those two things equivalent if you solve them? Okay. Yeah. 10 to the negative 2, I would move the 10 to the bottom and square it. 1 over 100. There you go. That works. Okay. Now, this way is usually a little bit easier to see. So on your assignment, you want to make sure you start with those problems first. Okay. Now, we can do the same thing going from exponent form to log form. Okay. Your base is the same thing. So as we start with 6 squared equals 36, to write it as a log, I write the word log. My base is 6, so my base is 6. My exponent goes to the other side, so equals 2. And my 36 is what goes on the inside. I always start with the base. And then I deal with the exponent, and I finish last. Okay? The next one. 4 to the 7th equals 16,384. We're going to write it in log form. So write the word log. Our base is 4, so put your subscript of 4. The power goes to the other side. And this goes with the log. 16,384. Put your comma in the right spot. And there's our equivalent log statement. Okay. Last one. We have a base of 2. So we're going to write log to the base of 2. The base is the same. Base is the same. My exponent of negative 3 goes to the other side. And this goes on the inside with your log as 1/8. Do I have them all? We're good? Okay. Questions that you're having right now? Today's goal for you is to be able to write back and forth with these. You're using your definition. We're starting slow. We're using your definition, getting exposure to using that definition, rewriting as each, so you can just see they're the same thing. It's the same as saying, hey, I've got 2x minus 7 plus 3y equals 0. I can move my 3y to the other side and say 2x minus 7 equals negative 3y. Those are equivalent equations, just like these are equivalent equations up here. It's just that it's no longer a linear thing. We're talking exponents and logs. Questions right now? Yeah. Yeah. I'm not waiting, Cody. Go get a drink. I'm going to move on. Okay. Okay. Using a definition of your log to evaluate. Okay. This time, notice there's not something on the other side of the equation. But all of these represent a number. They all represent a value. Okay. So what you want to do is off to the side, I would make sure you highlight this, you star this, you circle it, so that you're ready to go with it. All we have to do, yep, we're going to set that equal to x. We're going to put x on the other side, or set it equal to a letter, to a variable, as you said, Brady. I'm going to put this equal to x over there. And then it tells you, hey, use your definition to rewrite it as an exponent form. So now I set it equal to x, and now I've got my base of 2. This x becomes my power, equals 8. 2 to the what power gets us to 8? We got 3. Okay, so here x is 3, which means that this entire value right here is equal to 3. 2 to some power gets us to 8. Yep, and that power would be. So you can use your old exponent, what we just did on your quiz. This would become 2 to the x equals 2 cubed. Our bases are the same now, such your exponents equal. At this point now, we can utilize all those skills that we already have because we rewrote it. Okay? All right, so the next one down, log to the base 3 of 1. Okay, set things equal to x. Now utilize your definition and rewrite it as exponent form. Our base is 3. Our x becomes our power, equals 1. Yep, x has to be 0. So this log to the base 3 of 1, that really equals 0. I'd rather see 0 on my paper than log to the base 3 of 1, right? But they represent the same thing. Okay, last one on this slide. Log to the base 4 of 1/16. Set it equal to a variable. Rewrite it as a definition using rewrite it as an exponent using your definition. 4, our base is 4, to the x power equals 1/16. Now solving this one takes a little bit more time. -2. Okay. People are going to do this in different ways. Okay. Now we need the same base. Okay, so I can write this as 4 to the x equals 1/4 squared. We can rewrite that 16 as 4 squared. Do you agree with me? Now let's bring it upstairs. We want the 4 squared to come upstairs. So 4 to the x equals 4 to the negative 2. And now set your exponents equal. X is negative 2. So this entire logarithmic equation is the same as saying negative 2. Okay. Questions that you're having? Are we doing better than you thought when you started looking at your notes for the day? Okay. All right, now let's bring your calculator into things and find out where our limitations are. What does our calculator help us do? What doesn't it help us do? Okay. Log values are usually non-repeating irrational numbers that just go on forever and ever and ever. And so as you're pulling values off your calculators, you want to make sure that as you're doing that, that you have, you round to 3 or 4 decimal places. Don't ever just round to 1 or 2, because they're going to be minute changes based on 2.5 and 2.6 and those types of things. Okay, so make sure that you're rounding out. Now, your calculator, to use the log button on your calculator, notice there's no base here. Okay, I want you to think about this. What can you tell me if I had the statement x plus 4? What's the lead coefficient? Why is it 1? There's not a number there. It's understood to be a 1, right? Okay, so this number out front's understood to be a 1. What about the exponent? What's the exponent of x? It's also understood to be a 1 if it's not there. Okay, what about something like this? I take the square root of 2.5. What's my index? What's the number that's right here if I don't have it written there? It's understood to be a 2, right? So when we have a log that doesn't have a base written next to it, it's understood to be a 10. So this right here is the same thing as saying log to the base 10 of 2.5. I don't have to rewrite it as log to the base 10 of 2.5. What your brains need to understand as you're training them is that when you don't see the base and you see the word log, it's understood that the base is 10. And this is when you can use your calculator. Yeah. No, okay, and that's what we're getting to right now, okay? So get your calculators out so you can understand your calculator. Now, everyone's calculator is going to be similar yet different in the way that you put things in, so you have to know yours. Some of you will get blinking boxes. Some of you will get parentheses, okay? So when you go into your calculator, which we'll pull ours up, okay, and I'm going to clear everything out, okay, and you hit your log button. It's understood to be the base 10. What do you want to take the log of? We want to take the log of 2.5. We just put in 2.5. Okay. Now, if we go back and we don't close out the parentheses and I just put in 2.5, don't close out the parentheses, hit enter, it gives me the same result because nothing followed that 2.5. Are you with me? Okay. So as we look at this, it's 0.39794, yada, yada, yada. We said round to 3 or 4 decimal places. Don't go any shorter than that. So your answer here, when we go back to our slide that said, hey, it's the log of 2.5, if we round this, it's going to be 0.398 would be acceptable, or 0.3979. Don't go any shorter than 3. Okay? All right, now, if we go, the next one on your slide, as you're looking at your notes, is log of negative 2. It didn't work. Huh. Log of negative 2. Did you put it in right? Oh. We can't take the log of a negative number. Okay, so go back to your slide, and your calculator tells you, hey, it's not a real answer. It's a non-real answer that's there. We can't, this value right here cannot be negative. So we just say this is undefined. Your calculator kind of spits out error. Don't write error on your paper. Answer it as undefined. Okay. All right. Now, What is that? ln. It's ln, yep, it is. I don't see log. I don't see a base. But do you have an ln button on your calculator? Yeah, you do. So you could put this in, ln of 18.42. Say it again, Brady. What'd you get when you put it in? Give me the next. Are we good? We're good? So you could also put 0.914. Now, you probably want to know what ln means because it looks a little different than log. Okay? Is that not right? Okay. 2.914. 134? Oh my gosh. All right, there we go. Is that good? Okay. Now, what ln is it's a log with the natural number as its base. So if you think about our natural number that we said was e, ln is an abbreviation for log to the base e of 18.42. And instead of writing log base e, which is a lot of writing, they simplified it down to ln, saying it's a log with a natural base. L for log, N for natural base, and it's understood that that's log base E. Okay. I like using ln a lot when I have a choice because it keeps your paper cleaner because it's just on one line versus the log, the G goes down to the second line and kind of goes into that next line that you might be using. So ln's a little bit cleaner. It doesn't really matter if you have a choice. I use ln a lot. What I want you to be careful of when you're using ln is some people read this as 1n, that it's a coefficient of 1 and n is your variable. So if that's you, maybe you want to do a lowercase cursive l. ln is what you'll see a lot when I put it on the board. Okay. The same rules hold true with our natural log. I still can't take the log of a negative number. So if you hit your ln button and then put in that negative 0.034, you're going to get a non-real answer again. It's still undefined. I would definitely somewhere, though, make note that these two things are the same. You won't ever see log to the base e equals something in a book unless it's defining what ln is. You'll always see ln. So make sure you've made that note somewhere so you have it to look back at. We're almost done. Okay. Now, watch your parentheses. When you use your calculator here on these particular problems, watch your parentheses. Okay? This is telling you, order of operations wise, you're going to take the log of 7 and you're going to divide your answer by 5. Okay, so if we go to put that into our calculator, okay, if I go to put in log of 7 divide by 5, oops, let's clear out of there. Okay, if I go log of 7 or divide by 5, and I didn't get out of my parenthesis is still saying I'm taking the log of everything that's following and still in my parentheses. So when I have something like log of 7 over 5, that 5 is on the outside of my log. I have to close out my parentheses. I come back, close out my parentheses, and then divide by 5. This will take the log of 7, calculate that, and divide your answer by 5. Okay. If you're not quite sure if your calculator is doing it accurately, then make sure you just say log of 7, hit enter, and then divide by 5 at the end. Did you get the same answers? Yeah. Okay. At 0.169. Okay. And then here where it says that last one versus log of 7/5, that's all being put in together. So when you put that into your calculator, log of 7 divided by 5, that's going in together. You can close out your parentheses. You can keep it open because there's nothing following that. You're going to get the same thing. Do any of you have the blinking box? Okay, then you just have to arrow out of it when you're done with the log part, right? So that's why it's important for you to know your calculator. Okay? Questions that you're having? Okay? Now, the assignment for tomorrow is on that next slide. Okay? Now, I want you doing them in this order. I rearranged the order for a reason. Okay? These first ones that are here, this is you're going from log and you're writing it as an exponent. That's the way we started our notes. We started with the log form and we rewrote it as an exponent. The next 6 that you have starts as an exponent and you're writing it as a log. And then in the next ones you're evaluating and then you're using your calculator. So if you do them in this order and your notes are handy, look back at what we were doing with our notes. Attempt everything. Come in with questions tomorrow so that you're ready to talk about the graphing portion and stuff that we're working on tomorrow. Questions?